Hello everyone, this is solution video for quiz 9. I thought I'd just talk at you about it. I've got them all solved out. So let's see. Sorry, it's a little early. That 9:41 a.m. is not really the time. It is 6:30. Yeah, so for number one, we just basically had to reproduce the problem, and I wasn't really expecting anyone to go beyond the spreadsheet on this, but here's how one would if one wanted to. Um, 687 days to choose from, 20 class members. So the number of possible pairs later. The number of possible pairs, that would be just that exponent right there. And then here's the expression we need to figure out the number of pairs that won't produce two people with the same birthday, right? And we had to kind of fake that with the combinations function. And the idea there is that when mathematicians find themselves computing something a lot, they tend to give it a name and put it in a table somewhere, or make it so a computer program can just do that for them. And there's two of them. There's combinations. Combinations is when, say, getting a 1 and a 2 is the same as getting a 2 and a 1, right? Yes. But what we want is we want permutations. Permutations just don't divide by that factorial k. If you remember when we were looking at the Excel command for combin, we had to multiply by factorial k to cancel that term. We're not going to have to do that if we use this permutation function. So that's just notation there. It stands for doing the exact same thing in Excel that we've been doing. And most people got 24%-ish. That is indeed correct. With 108 students. We saw that in class as well. I believe most people got about 0.9998 for that. Oops. Let's write that down. 0.9998. And we could calculate in that Excel. What I'm really asking here is, okay, what about 250? Because that was the first thing we had. So can't do Excel, can't do calculator. There's a program called R. I'm going to try R. So I tried it on this computer. It ran too slow. So then I opened up the app state server for this computing program R. And this has been running for 15-ish minutes, and we don't have an answer yet. So maybe by the end of the video, it'll spit something out. I'll let you guys know in class if it doesn't, what the actual answer was. So, but again, it's that same calculation. Yeah, so let's move on to number two. Number two, so this is blackjack solitaire, just some simplifying things so we can calculate probability without having to worry too much about the details. For part A, the easy way to go about it, and I did actually brute force this calculation. If you want to know to do this the right way, or to do this straightforward, like to calculate the probability of at least 110, here's what you would have to do. Add page below. So let's think about it. What are our options? To get at least 110, right, we had to get 10, then something else, or something else, 10. Okay, so what would that look like? That would look like, so 16 out of 52 times 36 out of 51, right? Because we have one 10 card and one not 10 card. And that would be, and also we would need the 36 out of 52 multiplied by the 16 out of 51, right? So this was, I got a 10 first, this is 10 first, 10 second, and then the 10 and 10 option, right? But notice, I can switch this order, right? This is multiplication, so I can just kind of do this and make this multiplication on top and bottom. If I do that, I can flip this, I can flip that. So this is really just the same thing. It's 2 times 16 times 36 over 52 times 51 plus 16 times 15, 52 times 51. So there's our three options, right? You can see our ORs are turning into adds when we calculate probabilities. And if you compute that, you get exactly the same thing as doing this. So what's the point, right? Well, the point is that I did it both ways to make sure. Okay, so if we do that, we get about 52%. Probability of calculating a 10 and a 10, well, I've actually already featured that as part of this problem. So, yeah, that comes out to about 9%. So then the next question says, suppose you have two 10s. What's the chance your next card you draw will be an ace? And so you've already had two cards. So most people got this part. Most people got that it was going to be 4 out of 50. But I think I was even missing the detail, helping some people in class, that it was the probability 10 and 10 and an ace, which comes out to 0.7%. All right, let's check that calculation real quick. How's that going? Oh, nothing. Well, I didn't crash the server. I've done that before. Okay, one more to go. Okay, so this is straight up probability tree, multiply probabilities down the branches, go for it. But I've stepped it out a little bit more here. So let's just look at that. So there's a probability tree, split TB and not TB, then diagnosis, not diagnosis, or positive test, not positive test. And then we're going to apply this formula here. So the idea is that I need the probability of TB and getting a positive test divided by all the possible ways to get a positive test. And if we compute those, so these are just multiplications down the branches. Chance of TB is 0.05%. Chance of getting a positive test, if you have TB, is 0.999. So multiply those through, get 0.04%. Possibility that you have TB at all is TB and a positive test and not TB and a positive test, right? So that combination gets me 0.01. So I divide those two numbers and we come out with about 4.8%. So if you get a positive test, there is a 4.8% chance that you have TB. And this is why we do multiple tests. This is why we do tests to confirm once we've already done a test. All right, guys. I'm going to stop this calculation. I don't feel like it's worth making the server crap out for us. Maybe what I'll do is I'll turn this on for the day, just start RStudio and run this calculation all day on my desktop in the office, and we'll see how that runs. Anyway, hope that was helpful for kind of discussing probability and kind of the details of that quiz. Anyway, hope you guys have a wonderful day, and I'll see you in class around 2.